In this video, we'll be returning once more to the right triangle trigonometry. However, we'll be looking at the right triangle trigonometry through the eyes or the view of a circle or the XY coordinate plane. Now, if we're given that the terminal point or the terminal side of an angle lands at this point, that means that in the XY coordinate plane, I'm going to have my standard position, so my initial side starts here, and -4, 3, that's going to be over here. So 1, 2, 3, 4, 1, 2, 3. That's going to be where my terminal side passes through. Keep in mind, I'm going to go ahead and draw this as accurately as possible through that point. Okay. And this is where the terminal side of the angle ends. So the angle is actually going to be here. Now, what's nice about the unit circle, or any circle for that matter, is that I can always, given an angle, create myself a right triangle out of this information. Now, it looks like I haven't drawn this completely to scale, but I'll just go ahead and over-highlight it with that. Okay, so now, in this image, I have a point. This point is labeled as -4, 3. And there's my right triangle, sitting, again, as its angle measure coming from the center. So the question is what are all 6 trig functions based on this particular point on the XY coordinate plane? Now, if you're looking at a unit circle, remember the radius is always 1. But this right here is an x value, and the x value sits on this axis, so that's a -4. The y value is a 3, that sits on this axis over here, so that's 3. And you'll notice that we're missing our hypotenuse value. So if it helps, I'm going to go ahead and pull this right triangle out of that circle, or again axis, and I'll see this length is 4 and this length is 3. Now make note here that this is technically still negative. Okay, now in the XY coordinate plane it appears negative. It's not really a length anymore, so we're going to make sure that we treat that this length right here on the triangle is a positive length, but we're actually going to make sure that when we write our answers that it remains negative. Now, one other detail that's important about the hypotenuse of this triangle and the hypotenuse of any triangle in the XY coordinate plane, it will always be a positive number. There will never be a time where your hypotenuse is negative. So I'm going to go ahead and solve for that missing side, that hypotenuse side, by using, again, one more time, the Pythagorean theorem. 3 squared is 9, 4 squared is 16, and you'll notice once again that I have a 3, 4, 5 triangle where my c is equal to a positive 5. Yes, I know when I solve I get plus or minus, but again, remember, our hypotenuse will always be a positive value. So now that I've, again, created an angle from a terminal side point by creating a perpendicular perpendicular to the x-axis right triangle, I will simply go ahead and pull that right triangle out here, finish it off knowing what all the sides are, and then I can go ahead and fill in my values. Sine of theta, based on this triangle, theta being here, again, theta is always the central angle, will be 3 over 5. Now notice that's the same as the previous video. But if I look at cosine of theta, now based on the information we were given, cosine of theta is actually -4 over 5. And yes, keep in mind that the negative of this cosine does imply that the actual triangle or angle we're working with lands in this quadrant here or this quadrant here. Okay. Our next one is going to be tangent of theta. Tangent of theta is going to be, again, 3 over -4. Now you'll note here that I could technically pull that negative out and put it like this, and there's nothing wrong with that answer. This is the same thing as this, and that ratio will always be the same. The only difference is the fact of where I put this negative. Just make sure that the negative is in there. So there are your first 3 trig values, and again, remember, I'm not going to go back to the triangle for these next 3. I'm going to look at cosecant of theta. Cosecant of theta is simply 5 over 3. I'm going to go ahead and look at my secant of theta. My secant of theta is 5 over -4, which again we can rewrite as a -5 over 4. And then my tangent, which is going to correlate to a cotangent, is going to simply be a -4 over 3. So there are all 6 of your trig functions based on a given point on the XY coordinate plane. Again, notice my radius does not have to be 1 for me to work with the triangle that looks like this. Now, if we're working in the unit circle, however, and I simply give you a point on the unit circle, you can simply return to the unit circle values, knowing that this radius is going to be always a value of 1, and the x and y are going to be entirely based on the angle measures that we were given